Hi, this is Yuji. In my presentation today, I will start with project review. I will briefly summarize what we did in the Tula project. Then I will talk about what I have done to improve this project. In the third part, I propose some improvements regarding predicting purchasing behavior, which are sequential pattern matching, sequential market basket analysis, and improvement for churn rate analysis, which is clustering, and some suggestions for further analysis by gathering more data. Finally, I will justify why these improvements are beneficial to clients. So, project review. The three objectives are defined by the client. They are database architecture, predicting purchasing behavior, and churn rate analysis of auto delivery. Because Tula have the business problem that pull data from various platforms and does not have a shared repository to host their data files. We recommended Microsoft Azure because it is affordable, has 1 year free trial, and fast and convenient enough for current data management. Tula also found there is a need of predicting subsequent purchase, so we recommended market basket analysis that can identify the frequent combination so that we can recommend the customers to buy product they potentially like. Then, because there are relatively high churn rate in auto delivery program, we recommended decision tree model to analyze product size and frequency, because according to user cancellation survey, their major reasons to leave is having redundant product before the next delivery. It is a very comprehensive project that covered most of all major business problems that are usually faced by startup companies, especially for e-commerce. We slowly changed our mindset from a student to a real-world business problem solver by fully considering client companies' existing information so that we can design the personalized methodologies and solutions. For example, we recommended the warehouse type that most suitable for Tula's existing and future data volume, suitable for the budget, rather than recommending the most fancy data warehouse. In a purchasing behavior analysis, my colleague treat the whole historical purchases as a basket since customers usually don't buy a lot of skincare product in one order. In a churn rate analysis, we considered qualitative information, which is the cancellation survey, to focus on the key factor to analyze. So you can see that we adjusted our methodologies as we went through the process. Then in the project, I am responsible for analyzing the churn rates of auto delivery program. My partner is Yu Zheng, and we work together. And there is no clear boundaries between the work we do since we pretty much discussed everything that we're going to present. At the beginning, we identify the churn factors that are discounts, which represent the affordability of customers and the product quality, because I might quit the auto delivery because the product does not work for me. Then in the proof of concept stage, we tested the churn in terms of discount and different products, and found out that discount is not the major reason to churn. And analyzing specific product may not be effective because the rare purchases will lead to extreme values. Then we incorporate the cancellation survey information to change our focus to delivery frequency and product size, as they affect the usage and redundancy of the products. We also abandon personal factors that influence churn because Tula does not have a lot of demographic variable. Then, to perform the data analysis, we need to get data clean and structured as we want. So we cooperate with colleagues from data warehouse design team to select key factors, key variables, and build up overall relationship in data warehouse because everything needs to be consistent. Then we build up the model As we build out the model, we realized that product information will make all the product information will make the decision tree model that's super massive and ineffective. So we cut the tree by first analyzing the overall product type. Then for each type, we build up corresponding trees to present churn rates. And finally, to make our result easier to read, we turn trees to table to visualize. So in the whole process, we keep questioning, testing, adjusting, and exchanging information with other people in the group so that we can improve and finalize the results. In this slide, I will propose the change to our existing purchasing behavior predicting methodology. Our team member Tianxin used market basket analysis, which gives static combination of products instead of a sequential flow of purchasing. You can see from the result that it only counts for frequent combination rather than frequent sequence. So I propose to use sequential pattern mining that identify the frequent sequential patterns. Each sequence represents the items purchased by a customer at different times. A sequence is an ordered list of different item sets. For example, in this database, the first sequence indicates that a customer bought some item A and B together, then purchased item C, then purchased item F and G together, finally purchased an item E. What we need to do is prepare the customer purchasing history to a sequence data table, a database or data table, and then set the minimum support threshold. It is a minimum number of sequences in which a pattern must appear to be considered frequent. If we set 2, the result are the sequence at least appeared twice. So the output will like this. We can use the SPMF to perform this analysis. It is an open source data mining software, include a lot of functions such as clustering, classification. However, there might be one problem for market basket analysis and this sequential pattern mining is that it discounts the rare items. For example, if Tula has just have a new product or the product that is not frequently bought by customer, but actually has very high satisfaction and lead to more purchases, the market basket analysis and sequential pattern mining won't list it as a frequent sequence. So we need to account for the probability that how the product leads to the next purchase, right? So I will introduce another method to calculate the importance. The second method is the sequential market basket analysis. Similarly, it analyzes the acquisition sequence from the observed product portfolios. So how is it different from traditional market basket analysis? Let's take a look at their algorithm. As introduced in the final presentation, the one of the main measure of market basket analysis are confidence. It is a conditional probability of buying B given A was purchased. It is a probability that A and B bought together divided by the probability of buying A. And for sequential market basket analysis, it calculates the conditional probability of buying B after purchased A. It is the number of purchases of the B after A, then divided by the number of purchases of the buying B after A, plus the number of purchases of A alone. In other words, the probability of A to B is the probability of buying B after having bought A and excludes all the scenarios where B is purchased before A. Then we calculate the gain. It is a probability of A to B divided by probability of buying B, then -1. It is the percentage gain or loss in purchase probability for product B due to purchasing A. And when we compare the two methods, we can see that gain measures how prior purchase of one product affects the likelihood of subsequent purchase. And the confidence, support, and lift only influence the joint occurrence of the events. And the most interesting application of sequential market basket analysis is the rules it gave. So by assessing the magnitude and positive and negative sign on the probabilities, we can see the relationship between different products. They are weak and strong A to B sequence, complements, substitutes, and independence. Tula might be more interested in the strong A to B sequence because their product function and type are very clear, so we don't need to identify the substitutes and complements. Then strong A to B can give Tula a clue what is the gateway product. So what does it mean, the strong A to B relationship? It means that prior purchase of A increases the likelihood of buying B, then prior purchase of B reduces the likelihood of buying A. So in this sequence, A is a clear antecedent of B. The advantage of this method is that because the observed purchase sequences are actually affected by the website layout, but this method normalizes this kind of scenario by the number of times a product is purchased first. It corrects for the sample size differences, so it will not affected by how the website is designed. Right. And here I also proposed the improvement for auto delivery program, which is the cluster analysis. It is to group customers according to their main characteristic. For example, we can assess their purchasing power, which can be average value of an order, and loyalty by using number of auto delivery completed before the churn. Or the stickiness, we can measure the number of auto delivery program enrolled simultaneously or the time between the orders. So after we get this information, we can list it, arrange the data in this format. So first of all, the customer ID, and then listed the corresponding value. So after the cluster analysis, the output will be which customer belong to which cluster. So within a cluster, the purchasing power, loyalty, or stickiness are similar for the customers within this cluster. Then we can perform the decision tree model we just used, that is to classify and predict the churn rate for each group under the product category, delivery frequency, and product size. So why do I propose the combination of the cluster analysis, cluster then predict method? Because usually this method can have a higher goodness of fit compared to simple decision tree model, because it captures a different behavior, for example, in this case, the churn within each group. I also have suggestions for Tula that gather more customer personal information for future data analysis. For example, the gender, the birthday. The importance of knowing the birthday is that we cannot only know their age information, but we can also set up a system to send out the birthday gift when it is their birthday. And also the race, most importantly, the skin type, skin concern, and even the occupation category, because different customers have their different purchasing behavior does this information are very helpful to identify the customer cluster and then predict the purchasing behavior and the churn rate. So what can we do about the sequential result and clusters? Why they are actually improving the result? First of all, we can identify the gateway products, right? And because there are different type of customers could have different gateway products. So after we know the gateway products for different type of people, we can promote the product through recommendation system or through the personalized and target email marketing. So for the recommendation system, we can just display the information on the website, or we can pop out when customer put the product into the cart, or when they check out, or when they enroll in the auto delivery program. And for personalized and target email marketing, we can send out the differently designed email letters to the customer by their location, by scheme concern, by past order, so that customer is targeted and the information delivery is more efficient. That's all for my presentation. Thank you so much for watching.